Okay, this video is going to introduce us to control structures will cause the compiler to make decisions, and the if structure. So right now we're going to be talking about, first of all, control structures. If you notice on your notes here, it says control structures are programming blocks that can change the path we take through those instructions. And so what happens is, in what we've done here recently, is that we wrote programs where the compiler just starts at 7 here, it's going 8, 9, 10. It's just going down, going the next line down all the way through. There's no deviation. It's just, and every line is executed, except of course the comments. So that's what we're used to doing. But now we're going to write code that where the compiler will actually have to make a decision. Do I execute this line or do I ignore this line? Or basically, do I execute this block of code or do I ignore this block of code? And so programmers write code that instruct the compiler to make a decision between one or more options. Alternatives or possibilities, you call them different things. But all computer decisions are based on whether something is true or false. So just like if you're walking out of your house to take a walk, you look out the window. If it's raining, if it's true that it's raining, you take your umbrella. You have to make a decision. If it's raining, you take your umbrella. If it's not raining, then you skip it. Alright, and so that's the idea, that you're going to actually program the computer to make those kind of decisions. And they're always based on whether something is true or false. These are called Boolean values. Boolean, B-O-O-L-E-A-N, Boolean values is what those are called. And the other thing is, is that if Boolean values are true or false, we want to do a lowercase t and a lowercase f. So those are the Boolean values. The Boolean is actually a data type for variables. So just as ints only store integers and doubles only store decimals, Boolean variables only store true or false, again with lowercase t and f. And so and we'll see that here in just a little bit with the Boolean data type. The decisions will be made based on the value of what we call a Boolean expression. A Boolean expression. And we'll illustrate that a little bit more as we go along. Boolean expressions use relational. Oh, that's weird. Okay, we're going to go over here. Either they use relational or comparison operators. Relational or comparison operators. So if I said compare the numbers 2 and 6, you might say something, well, 2 is less than 6. Okay, you just compared them. What is the relationship between 2 and 6? Well, 2 is less than 6, or 6 is greater than 2. That's why those terms are used, because that's exactly what we want the compiler to evaluate, is regarding something being greater or less than or equal to, etc. So greater than, of course, we're going to use symbols in here that are similar to what we do in math class and so forth, but the greater than symbol obviously is 1, and less than is an obvious 1. Now the greater than or equal to is a little bit different because it's two symbols, so greater than and then the equal sign with no space in between, and then the less than is less than symbol with the equal sign, no space in between. And then the other thing is that equal to is not equal sign. The equal sign is an assignment operator. It says something is being stored in a named memory location, but we put two equals, so we put two equal signs together, and that is going to be a comparison or a relational operator with no space in between. And then the not equal to, the exclamation point means not and then equal to. Alright, so how does this Boolean expression work? Well, what happens here, here's some examples of Boolean expressions. So if you have num1 is 5 and 8 is num2 is 8, and you go, okay, well, here's num1 and its return value is 5, and you have num2 whose return value is 8. Alright, so it looks like, well, it's saying that 5 is equal to 8. And so here's the important thing, is when the compiler sees a Boolean expression, it evaluates, so right here, it evaluates it to be true or false. So Boolean expressions are automatically evaluated by the compiler to be true or false. For num1 equals num2, in this particular case, it does not say that 5 is equal to 8. What it does is it evaluates the expression 5 is equal to 8 to be false in this case. So it evaluates this to be false. And then, of course, you have these other Boolean expressions. The same kind of an idea is going to happen. Some of these are true, some of these are false. So, for instance, this one, num1, 5 is not equal to 8. Well, that actually is true. So, that would be a lowercase t-r-u-e. Alright, so, if we look at an example of how this works, here's num1 and num2 again. Boolean, just like an int, is the data type. The variable name is result, sets up a those two words set up a memory location and it names it result. And it's assigned, or what it's storing in there is the result of this particular Boolean expression. It's the value of that Boolean expression. Well, remember we said Boolean values are true or false. And so as you look at this and you go 5 is greater than 8, you see that that is actually a false statement. And when a Boolean expression, when the compiler sees a Boolean expression, it looks at it and says, okay, is this true or is this false? This is, of course, false. And so then it's going to store false in this memory location. And so when this print statement is executed, it's going to print the value of result, and so it finds the variable result and returns the value false, and that's what it prints. Alright, so that is how that works. So there's a value given to Boolean expression, but it's not something like we think of a value like 7 or 12.3 or something like that. It's either true or it's false, and I capitalized this and I wasn't supposed to, so it's a lowercase f. And so just to show how this actually works, we're going to go like this, and here's a little demo of a Boolean expression or a Boolean values. And so what we do here is we have basically what we have. Oops, I was going to do this. Let's do num1 is less than num2, just for kicks. And so we compile this, and then we run it. And so this is going to be evaluated to be true or false. It's going to be stored in result, and then that true or false is going to be printed here, displayed on the output as output. So here's how it goes, and you see how 5 is less than 8, so it prints true. Let's change the sign. Let's make it greater than. Well, so it should do false, which it does. You can also test it out by going like this. Let's just assign it false. Let's assign it true. Notice how it changes a different color if you're in the JGraphs type environment. So here, is it going to print true? And it does. Let's capitalize the T. Alright, you see it doesn't turn the color, and you'll see it has an error message that can't find simple because true is not a value with the capital T. And then if we put quotation marks around it, because heck, it's a word, and so it's a group of characters, it's got to be in quotation marks. Well, we got a problem here, because it sees a string, it sees quotation marks, it says that's a string, but it says it cannot be converted to Boolean. In other words, it can't be converted to true, just true, or false. And so there you have it. Let's go back to our notes and let's move on. Now this right here is going to be this is called an if structure. The if structure has only one choice, one option, one possibility. Like when you're going outside and you decide whether or not to take your umbrella, you look and you go, okay, my only option here is I'm going to take the umbrella, or I'm just going to skip it. And so that's what happens with an if structure. In here you notice that we have a declaration of a named constant, and the 70 is stored in it. That's the passing score. We're asking the user for a test score, so maybe they put in an 85. And now when you come down to here, this right here, this is called the if structure. Alright, so this is the if structure. It starts with the if and it ends with the final curly brace. And you'll notice that the first line is we're going to call this first line an if statement. Now technically the if statement can refer to the entire if structure, but most of the time I'm going to use this in terms of this particular line. It's just easier to relate to. This is what's called in geometry, you probably should be used to the word conditional. This is a conditional. So it's presenting a certain condition. It uses the word if. If this condition exists, then something's going to happen. And so this condition right here, here's your Boolean expression, and so this is also called, so make sure you write in here Boolean expression, and it's also called, we call it the condition. This is the condition, and you're evaluating to see if that condition is true or false. That's what the compiler is doing. Alright, and so here's our relational operator, comparison operator. And so if the user types in 85, then this return value for this variable call is 85, and this is 70. The compiler comes to this and doesn't say that 85 is greater than or equal to 70. It evaluates that to be true or false. Well, it calls this to be true, and because it's true, then it jumps into the this block of code. Now this is a block of code. When you have two braces, and we've talked about this before, so this is a block of code. And that's, I want you to write this because I want us to get used to the term block of code. And because we've already experienced two different blocks of code. So you can look at this code here, this illustration, and you would find that you do have a block of code. So it starts here. The blocks of code start with a curly brace and end with another curly brace. So this, we've already talked about this starting in chapter 1, that this was a block of code that is called the body of the main method. So that this block of code is the body of the main method. This block of code right here we're going to call an if clause. Now other people will call it an if branch, maybe an if block, but this is called an if clause. And so if the condition or the Boolean expression is evaluated to be true, the if clause is executed. That's all there is to it. And you see when you set up your code, as we practice writing code eventually, that you want to, whatever you type here, if it's true, you want to make sure that it that this, what's going on here, makes sense. So does it make sense that you passed if you got an 85 and the passing score is a 70? And so of course that's true, so that's why this makes sense. What happens if they get a 65? Well, 65 is going to make this false, and so it's not going to execute the if clause. It just ignores it, and then it goes down past the if structure and goes to the rest of the program. So in here it would make sense to thank you, your score has been entered. No matter whether they passed or didn't pass, the score has been entered. So this is not inside the if clause, so it doesn't depend on the Boolean expression being true or false. It waits till it's done making its choice and then goes on to line 19 where it says thank you, your score has been entered. And so let's see if we have labeled our code. Yes, actually we have. Alright, and so if we then look at the last part, number 7, the if clause is executed only if the Boolean expression is true. And if the Boolean expression is false, number 8, the if clause is ignored or skipped. And so, and one last thing is that we do want to mention that what should happen when you test your code. And so I'm just going to put a note somewhere if I can find some room, is we want to test your code with the different possibilities. And so in this case, the score, the passing score here is what I'd like to call a boundary. And so a boundary is like a line around a volleyball court or a basketball court. And so your foot is either over the line, on the line, or inside the line. And so this passing score, which is 70, establishes a boundary. So anything over it or equal to it, that's two conditions, make it true. And then less than is false. So you want to go, you want to test a score that's less than, I probably should start with greater than, is greater than, you do one that's greater than 70. You test when you run your program, you test it with a score of 70, and then a score of, let's say, 60 or 65, and make sure that it is giving the correct output based on what would make sense. The last thing I want to look at is this right here. This right here is called an escape sequence, and we've talked about this before as far as printing quotation marks. This escape sequence, what this does is this moves the insertion point to the next line. Alright, it moves the insertion point to the next line. And so if we were to let's say run this example, then what happens is we compile it and then we run it, And so let's say that we do enter a score like 79, and so it says congratulations, you passed. Well, what happened here? So after this line here, and since we're using the print method, the user types the score on the same line as the prompt, which is right here. And so now the insertion point is sitting right here after the 9, and then the next output is going to be when it prints congratulations, you passed. So what happens is the print is engaged, and it says, okay, print what's in the quotation marks. The first thing in the quotation marks is an escape sequence that moves the insertion point to the next line. So it goes from here down to here. Oops, I shouldn't have said that. So sorry, when the user typed the 79, they hit enter, and so the insertion point went down here. Then this line came up, and it's printing this string, the code inside there, or the characters in there. The first thing is it moves the insertion point down, so to the next line down, and then it prints congratulations, you passed, and then the ln kicks in and goes to the next line. And so what this does is creates a blank line, which is what we wanted in the output. Alright, so that's the escape sequence for moving the insertion point to the next line. Alright, that should do it.